So this is section 10.1, chapter 10. This chapter is on statistics. First section is on designing experiments and collecting data. So data are measurements or observations that are gathered for a study. Let's first just go ahead and address the elephant in the room here, okay? Data is plural, so it's data are. I don't know about you guys, that does not feel right to me, but it feels like, data is, measurement or an observation. No, it's plural. So if it sounds weird to you, it sounds weird to me too. So, or maybe it doesn't sound weird to you. Maybe maybe you already know this. Statistics is the branch of mathematics that deals with collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on that data. Statistics is a huge field. In fact, most schools have a completely separate statistics department. Like, you can get a full degree, a bachelor's degree in statistics. You can get a master's degree in just statistics, a PhD in just statistics. It is such a broad field. Okay, there's so much awesome stuff. So it's not like it's just like a couple of classes that you take, in math. It's its whole, separate animal. So let's get some terminology down here. A population. So a population consists of all the objects being studied. A sample is just a representative subgroup of that population. So if the population is, say, all of Prairie State College students, you could take a sample, right, of the population by, just kind of picking out students here and there and, using them as a sample. You want it to be a representative sample, right? If you're trying to do the population of Prairie State College students, you wouldn't take a sample of just a math class, right? That wouldn't be a very good representative sample. You would want to use some other kind of sample, like, say, some kind of random sample where you just kind of randomly pick a whole bunch of different students. So anyway, there's two main branches of statistics. There's descriptive and inferential. Descriptive does just that. It describes. You collect it, you organize it, and you basically report it. You're like, here's what I found. Here's some pretty graphs that organize this data and will show you this data. And then there's the inferential statistics. These are the ones that get you in trouble. These are the ones that draw conclusions about the data that the descriptive statistics collected. They start making inferences, right? They start making conclusions based on the data. They look at the data and they're like, oh, well, we can clearly see that anybody who wears a shoe size of 7 or above has a low IQ, or something ridiculous like that, right? Because there's all these kind of joke graphs that have correlations, where you can look at a statistical correlation between data, and it's like weird stuff, like people who sleep late and people who like cheese. It's very weird. Or, the divorce rate and cheese consumption, or the, I'm trying to think of some of those off the top of my head. There was one, it was like being killed by getting wrapped up in your sheets. What is it with me and death lately? Like, that seems to be like all I'm fascinated by. I don't know, I keep coming back to it. I don't mean to. Sorry about that, guys. I'm really a cheerful person, I promise. I'm not just like hung up on death. Anyway, moving on. Awkward. In an experiment, the researcher typically manipulates one or more variables to see if there's any differences in the outcome. Much of the study of statistics deals with variability. Okay, that is how much something changes or varies. And that's all about leaving something fixed and letting something else change and seeing how the two groups, how they compare. That's why when we talk about like medical studies with drugs, we'll have a placebo group where they were given nothing or a sugar pill, right? And somebody else was given an actual pill, and see how the groups compare. So if students are measuring a cup of milk, in an actual measuring cup, okay, a standard measuring cup, what might cause differences in measurements by individual students? Well, you can have a lot of different things here. You could have some variation in the measurement cup size. If the students all have different measuring cups, you could have some kind of slight variation. In the cup size and shape. You have to take into consideration that you're working with kids, so they're going to splash some out. Right? They're going to slosh some out of the cup. It's not going to be as full as it should be, right? Some of them are going to overfill it. Some will underfill it. Those are just the three that came to mind. You may have some others to add to it, but that's just the three that came to mind. So I saw this question in the homework and I was like, oh, that's an interesting question. So, okay. Determine the population in each survey and whether the sample is representative of that population. So you ask 50 soccer fans sitting in seat numbers that are randomly chosen by a computer to rate the new stadium lights. What is the population? Well, the population would be soccer fans of, say, that team, right? If we're talking about the new stadium lights. So the population we'll just say soccer fans. The sample are the 50 soccer fans, right, that they're taking, that they're randomly choosing. And they're randomly choosing it by using some kind of random digit generator on a computer. So that seems like it'd be a really good sample. So that sample is randomly generated and is representative of the population. Now you may be thinking, so what would not be representative of the population? I'm glad you asked. To find the average distance that students have to travel to get to school, you survey the first 75 students coming through the main gate one morning. All right, so the population would be the students at the school. The sample is just the first 75 coming through the main gate. That's not a really good sample, right? Because it might be that the first 75 are the ones that live the closest, so it's easier for them to get there. If the students who have to travel farther may be later because of traffic, trains, whatever, right? Transportation issues. So just looking at the first 75, not going to be a very good sample. Also, it says through the main gate. What about people who maybe come in other doors? Is there another gate? I mean, the fact that it said main gate, kind of, triggered something with me. I was just like, well, maybe they mean that could be other gates. But basically, this is not a good sample since students who live farther may not be the first ones there. To find the average numbers of bicycles that are owned by a typical household in your town, you poll every student at your school. All right, so the population is what? Well, it's people in your town, not the people in your school, because it says the average number of bicycles owned by typical household in your town. People or households in your town. So the sample that's being chosen is students at the school. Is that a good sample of the population? Well, no. That's only people who have, that's only kids, right? Adults have bicycles. Plenty of adults have, I got a bicycle. My husband's got a bicycle. Plenty of, people who have kids have bicycles, but also people who don't have kids have bicycles. So we'll say the sample does not account for, we'll say households where maybe you have a student at another school, maybe you have a student who is out of school, maybe you have a kid who's not in school yet, or maybe you don't have kids. So we'll just say for people who don't have kids at that school. So it's not a very good representative of the population. In order to evaluate statistical claims, students must be able to formulate statistical questions with no bias, collect the data, analyze and display the data, and then interpret the results. Now, let's start off with this, the no bias thing. When you're formulating a statistical question, you should avoid questions that have some kind of inherent bias to them. So what do I mean by that? Well, I wrote up some questions, and I figured that seeing examples might be better than just kind of trying to talk our way through this. So I want you to label each question as either fair or biased. Do you think that each question is a fair question that does not have any kind of leading, insinuations to it? So pause the video, go through these, and just label them as which ones you think are fair, which ones you think are biased. All right, so part A. Do you prefer sweet dogs or demon cats? Come on, that's a biased question, right? That's got some bias to it. The person asking, if you're asking that question to somebody, they're going to be ashamed to be like, oh, I love cats. I love those demon cats scratching my eyes out and stuff, Yeah, so this is a biased question. If you were to say, do you prefer dogs or cats? That would be a fair question. What is your favorite shampoo? Fair question. Did you enjoy the amazing presentation? That is a biased question. That has some bias to it because you're leading that person, right? You're going ahead and you're giving your opinion with the question. Should concerned dog owners vaccinate their pets? That is a biased question. You should say, should dog owners vaccinate their pets? By saying the word concerned, you're insinuating that if you don't vaccinate your pet, then you are not a concerned pet owner. So by saying that, you are making the person that you're asking the question of feel, kind of uncomfortable. And you're making them feel like, okay, well, I can't give you my honest opinion. And data is, it's important that you get people's honest feedback so that you have good data. How many hours of sleep do you get on an average weeknight? That's fair. collecting data. Much like formulating a good question, you should avoid bias when collecting data. You want a sample that is representative of the population with data that was collected in an unbiased way. So, for example, if you are conducting an exit poll of voters, an exit poll is when somebody stands outside of a polling place and as people come out, they ask them, who did you vote for? Right? So that's an exit poll. They say, hey, who did you vote for? And if they're willing to tell them, then they take that data. And that's how the news people are able to use these predictions, these exit polls, to make predictions about how elections are going, to turn out. Now, if you're conducting an exit poll and you're wearing a Biden-Harris shirt, the data that you collect will be biased. People may lie to you about who they voted for to avoid confrontation or judgment. Right? So something as simple as that. And this has been a really big item when it comes to the election and, how Donald Trump won the election in 2016, because all the exit polls said, no way, it was Hillary Clinton. And then boom, right, Trump wins. And everybody's like, how did this happen? Because, it could have been some, bias. It could have been that people were embarrassed to say that they voted for Trump. It could be a whole slew of things, but a lot of it was suspected to be some kind of statistical collection bias that worked its way in. Analyzing data. Once data is collected, we must decide how to display and summarize the data. This is discussed more in the next two sections when we talk about how to graph things. All right, almost done. Last page. Interpreting results. Some data have clear results. Other data are more open to interpretation. This step is where the misuses of statistics occur. Okay? When you see a result like 95% of people voted for Trump, you're like, wait a minute then. How did, here's the kind of stuff you need to go along with that data, with this statistic. You need information. You need to know what question was asked. How many people were polled? Where and how were they polled? If you say 95% of people that you surveyed voted for Trump, well, did you ask, 10 people in, rural Mississippi how they voted? Or did you ask, 8,000 people across the country? That's a big difference, right? Is your sample representative of the population? How many people responded? How were the people chosen? There's a lot of information that's missing. So a lot of times when you hear statistics, don't always believe them. News outlets especially will lie to you when it comes to statistics. Not lie, mislead you. That's a better term. So it's common for companies and news outlets to use misleading statistics to want to sell products or push some kind of agenda. Don't be afraid to question statistical results. Okay? I know that like some news agencies, when it came to this last election, were saying, oh, our polling is all showing that, people are voting for Trump. A lot of news agencies would say that because people tend to want to vote for the winner, right? So some people may be like, well, I guess Trump's going to win anyway, I just shouldn't vote. Or I guess Trump's going to win anyway, so I should just go ahead and vote for him. So sometimes there's an agenda, a political agenda at work. So basically just keep your eyes peeled. And when you hear statistics, don't be afraid to ask questions and go find the data that goes with this stuff so that you can make an informed opinion on the statistics that you were given. Because just because somebody interpreted the results one way doesn't mean that's how somebody else would interpret them. All right, so that's the end of section 10.1.